Welcome to the last section on quadratic functions for Algebra 2. This section, we will be discussing quadratic inequalities. So for the first problem, we are just going to graph the quadratic inequality. So what that means is we are going to take our quadratic, graph it, and then we're going to shade. So we have a lot of different ways that we can graph our quadratics. We looked at finding the axis of symmetry, which was negative b over 2a, and then graphing it from there with the axis of symmetry, the y-intercept, and finding the vertex. And then we also found the graph by completing the square. And then once when we have completed the square, we have our vertex, and we also know the way how we're changing with our a value. So I'm going to complete the square here. All right, so for starters, to complete the square, we need to pull the negative 2 out. So we have y is less than negative 2. If we take that out, we then have a positive x squared minus a 3/2 x, and then plus a 5 at the end. And then we take our negative 3/2, we divide that by 2, which is the same as multiplying by a half to get 3/2 divided by 2, so multiply by a half, which is the same as 3/4. And then square that to get 9/16. So here I'm adding 9/16 on. And then since I'm adding 9/16 and I'm on the same exact side of the equation, I want to subtract 9/16. And this 9/16 is being times by negative 2, so I'm going to times it by negative 2. So now we have y is less than negative 2, and then this factors down to x minus 3/4 squared. Negative 9/16 times negative 2 would be negative 9 or positive 9/8. And then we want to add 5 to this. So 5, if we write that, 5 plus 9/8 would be 6 1/8. So we would then say plus 6 1/8. So here is our equation written in vertex or standard form, in vertex form. So from here we can clearly see that our vertex is at 3/4 and 6 1/8. From the negative 2, we can see that our parabola opens downwards. So we'll put our vertex at negative 3/4 and then positive 6 1/8. It's about there, and this is going to be an approximation. And now we have that negative 2. So when we go over 1 in the x direction, we're going to go down 2 and put a new point down for there. Same on the other side, we're going to go over 1 in the x direction, and we'll go down 2 because we're timesing by 2. All right, then when we go over 2, we normally 2 squared is 4, but we're timesing it by 2, so we'll go down 8. So about right here. And then the same exact thing on the other side, over 2 and then down 8. And this really is an approximation because we don't have those an exact 3/4 and 6 1/8 on our graphs. Now we can connect those, and there we have our parabola. Taking a look, this says y is just less than. So it looks like I should have graphed this as a dashed line. So let's see, we'll just undo it and regraph it as a dashed line. Okay, so there's our quadratic graphed as a dashed line. And the less than sign tells us where we cross the y is right here. So we want to be shaded on the values that are less than that, which are these. So this quadratic would be shaded right here. So that's how we would graph our quadratic inequalities. All right, so we're going to now solve some quadratic inequalities. So we're going to solve this, and the first time we're going to solve this by graphing. So the first step that you want to do is we want to graph this quadratic. So we can put it in standard form. So x squared plus 2x minus 8. And then here, 2 divided by 2 is 1, and 1 squared is 1. So I'm going to add 1. And then over on the other side, I'm going to subtract 1. And 1 is just being multiplied by 1, so it's just subtracting 1. This then gives us x plus 1 squared minus 9. And this is less than 0. So here's my quadratic that I'm going to graph. So my vertex is at -1, -9. And I see my a out in front is just 1, so I'm opening up. So I'm going to go here to -1, -9. My graph doesn't go down that far, so I'm going to move my x-axis up. So I'm going to move my x-axis to right there. And so now I'll go -1, -9 for my vertex. And my a is 1. So when I go over 1, I go up 1. Over 1, up 1, because 1 squared is 1. When I go over 2 from my vertex, I'm going to go up 4, because 2 squared is 4. So 1, 2, 3, 4. Same thing on the other side. When I go over 3, I'm going to go up 9, because 3 squared is 9. And then I can graph in this quadratic. And we're solving for x, so you can certainly just graph it in. It doesn't need to worry about whether it's dashed or solid. The key here is because we're solving for x, we need to know exactly where this crosses the x-intercept, what the x-intercepts are. Graphing this one, we got the x-intercepts exactly, and they are at -4 and at +2. So those are our two x-intercepts. Now let's say we couldn't get that exactly from the graph. You could do two different things. You could take a look at this and you could factor it. So you could go, okay, well this factors to x plus 4 times x minus 2, and then solve those both for 0, and then you get your -4 and your +2. Or you could certainly do the quadratic formula on it to get your two solutions. It doesn't matter. You're going to get those two solutions regardless of which way you do it. And now we want to pay attention to the sign here. So the sign of the inequality says less than right there. So less than is going to mean that we want the values that are below it. So that less than. So here, when we look at this graph, our graph is less than in this section. That's where we are less than the x-axis. That's where our graph is less than the x-axis. So this tells us that our solutions lie in between -4 and +2. So our solutions here are all the values for x, where we are in between -4 and +2. So -4 is less than x is less than 2. Now, if our solution said greater than, so this is purely if it said greater than 0 here, on your graph, here's a portion of the graph that's greater than 0. So that would be referring to over here and over here. So if it said greater than 0, over here is x is less than -4, and over here it's x is greater than 2. So that would have been your solution if we started off with greater than 0. It just depends on where your graph is. All right, and last but not least, we are going to solve this, but now we're going to solve it algebraically, so with no graph. So first off, you want to get it equal to 0. So I'm going to subtract the 18 over, so we'll have x squared minus 3x minus 18 is less than or equal to 0. Then from here, you want to solve this quadratic by either factoring it or quadratic formula. I see that this factors to x minus 6 times x plus 3, and then you solve those both. So if x minus 6 is 0, x is 6. If x plus 3 is 0, x is -3. So this gives us two different points. So from there, we're going to put our two different points on a number line. So we need all the way from positive 6 to negative 3. So 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. And then we can fill our number line in. And then we're going to mark those 2 points. So we got negative 3 and we got negative 6. Or we got positive 6. Notice that this splits the number line up into 3 distinct places. We have a spot on the left-hand side. We have a spot in the middle. And then we have a spot on the right-hand side. So we need to decide which of these sections this actually is true for. So in order to do that, we can just test each section. So when I say test each section, we're going to pick an x value from each section and plug it into the formula. So let's say on the left-hand side, I'm going to pick x equals negative 6, because that would certainly be over here. For the middle section, I'm going to pick x equals 0, and for the right section, I'm going to pick x equals 8. And you can choose whichever numbers you want to in those sections. So now I'm going to test it from the original equation. So x squared minus 3x is less than or equal to 18. So if x is negative 6, we have negative 6 squared minus 3 times negative 6. We want to see if that's less than or equal to 18. Negative 6 squared is 36. Negative 3 times negative 6 is a positive 18. Well, we can clearly see that this is not going to be less than or equal to 18, because 54 certainly is not less than or equal to 18. So that means that this left-hand section are not our solutions that work. Okay. Now we do the same thing with 0. So we're going to plug it into x squared minus 3x and see if that's less than or equal to 18. Well, if we plug 0 in, we have 0 squared minus 3 times 0, which is just 0. And is 0 less than or equal to 18? Yes, it is. So that means that this middle section are going to be solutions that do work. And then finally, we do our third section, which is x equals 8, and we plug that in to our original equation. So x squared, so 8 squared minus 3 times 8, we want to see if that's less than or equal to 18. So 64 minus 3 times 8 is 24. 64 minus 24 is 40. And 40 is not less than or equal to 18, so this section does not work. What that tells us is that this middle section are the solutions that work. So our values for x that work here are the values that are in between 3 and positive 6. And we are using less than or equal to signs here because we started off with that equal to. So our solutions here are negative 3 are less than or equal to x, or less than or equal to 6.